Welcome to today's webinar. We're happy that you'll join us today for HiveMQ Kafka, the ideal HiveMQ and Kafka, of course, the ideal solution for IoT MQTT data integration. I'm Verena, and I'm happy to present you today's speaker, Magi, who is product manager at HiveMQ, and HiveMQ CTO, Dominik Obermeier. We will start in a minute, but before, I want to let you know that you can ask questions during the webinar by clicking on the Q&A tab below. Questions will be answered afterwards during the 15 minutes Q&A session by Dominik and Magi. If there is not time to answer all of your questions, we will answer the unanswered question on the HiveMQ community forum. Additionally, we will also start a quick poll during the Q&A session, and we would be pleased if you would give feedback on this webinar. And now I think we're ready to go, and I will hand over to Magi and Dominik.
Okay, so hi everybody, also from my side. My name is Dominik Obermeier. I am the CTO here at HiveMQ. And I've been involved with MQTT for a pretty long time. So I am a member of the OASIS MQTT technical committee, which specifies and standardizes the MQTT protocol. I am a regular conference speaker about topics like Internet of Things, about MQTT in particular, but also about architecture and technology. And I'm also a book author on these exact topics. And I have a strong background in distributed systems, and this is one of my favorite topics to talk about. And with me today is our product manager, Magi. She's also a conference speaker, she's an author, and she's an expert for cloud native technologies and technologies like Apache Kafka. And we will present you today how to build the ideal solution with MQTT and Kafka. And we will talk about architectures, we will talk about use cases, and how to apply this to your exact situation. So while we speak here, a lot of people are connected to the internet. So what you see here is a chart from 2005 to 2018, where you can see until 2018, almost 4 billion people, which is more than half of the people living on Earth, are already connected to the internet. So this is increasing rapidly, and it was increasing rapidly for the last 10 to 15 years. And in a few years, we can expect that almost everybody on Earth will have access to the internet. But also at the same time, something else happens. So now you see a chart here, and the exact same chart you saw below in the slide before, you see here as this line here at the bottom, which looks like a straight line, because what we see here is the things connected to the internet. And until 2025, 75 billion devices will be connected to the internet, which is almost an order of magnitude more than people live on Earth. So this is huge, and the Internet of Things is huge. And the technologies we need for the Internet of Things have specific challenges. Because we're talking about millions of devices. And even for small IoT deployments, usually we're talking about numbers of multiple hundreds devices, thousands devices, tens of thousand devices, up to hundreds of thousand devices, or even millions of devices. And usually these kinds of problems, companies who had these web scale problems solve these kinds of problems with technology, but now a lot of companies see themselves in a situation where they need to support millions of devices, huge data streams, and basically all companies who do anything in the Internet of Things space do have a big data problem. And there are multiple technical challenges for IoT. So when we really talk about implementing solutions for the Internet of Things, for millions of devices, or even if you have just a few hundreds of devices, the same technical challenges apply to you, most likely. The number one challenge here for many enterprises right now is scalability, because enterprises find themselves in a situation where enterprise IT infrastructure is not suitable for IoT problems. So things like cloud native, things like elastic scaling is something that is usually pretty hard for most enterprises, and the transformation processes required here are usually huge. And also the software itself really needs massive scalability, which is required for supporting millions of devices, especially if you have any numbers you need to hit when it comes to cost, which most of the companies do, fortunately. And this also means that the unit economics are important. And so the better software scales, the better your unit economics are usually. Another huge challenge for many Internet of Things deployments our customers and the industry sees is that end customers today are really spoiled. If you compare services, IT services from today to services 20 years ago, this changed in an extreme fashion, because people nowadays expect this instant user experience for data exchange. People are used to applications like WhatsApp, which allows humans to connect to any human on Earth in seconds or even faster, and have this instant data exchange. And the same is true for the Internet of Things. If you are designing or selling a service to your end customers where internet communication is required, and you don't have a snappy user experience, you get a problem. And if you're building a car sharing service, or if you're building a connected factory, it's basically the same thing. You need this instant data exchange because your end users probably need it. If you have human end users, because otherwise your product will suck. Or if you have, if you do this not for end users, but if you have a business problem to solve, then you also need this instant data exchange. And also at scale. So it's really about having this instant data exchange at scale with up to millions of devices, basically. And critical systems need reliable and instant data transfer. This is especially true if you go to domains like manufacturing, but also if you have end users. Every time something fails, you let the end user down, and this will hurt your product and your reputation. So this is also a challenge enterprises are facing today. And a technical challenge we also see nowadays is unreliable networks. What is really awesome today is in most countries, there is internet access available almost everywhere. So especially here in Europe, you have a very, very good coverage of wireless connectivity technologies. So, but even in large countries, like in the US, you have a really good coverage of mobile data. And the problem is with wireless networks, like mobile networks, is that these are unreliable. And the thing here is the customer experience for IoT applications and devices must be excellent, even if the internet connectivity is flaky, or if it's really not good, if you have very high latencies, very low throughput. Still, your customers demand excellent service. And this is especially true for moving devices, which you often see like cars, or also handy, like these applications for your mobile phone. These are moving IoT devices at the end of the day. But even if you don't have a moving device, chances are that you're still using a wireless connectivity technology, which is unreliable by default. And also devices and apps must be easy to program and to maintain, and complexity should be included in the cloud and not in the device. It's super hard and super expensive to update anything on the device. and it's very easy to update and roll out functionality on the cloud side. So so people who developed physical end user devices for a long time know that it's a very huge problem to roll out software updates, because you will never update all your whole fleet. So the thing is, you really want to have the complexity in the cloud and not in the device. And really it boils down to the thing here is really the web technology, which is used today for building the Internet of Humans, is not suitable for the Internet of Things. And also, one thing that the internet history told us is we need open standards for in general, because open standards will win at the end of the day. But also, we need open standards which are explicitly designed for the Internet of Things. And open standards are important because if you just have a single vendor for anything, which is in your value chain as a business, this is a massive problem from a risk perspective. So one of the most popular, and basically the most popular technology for the Internet of Things, which emerged since 2010, is MQTT. And I think most people probably know MQTT, but if not, let me introduce it quickly to you. MQTT is an IoT messaging protocol, also used heavily in industrial IoT, and is created for extreme scale and instant data exchange. It's based on a publish-subscribe architecture, and it's very easy and trivial to implement on the device side because it pushes all complexity to the server, means to the cloud, which means updating and bug fixing and everything is much easier than if you do it on the device side. So an MQTT is really designed for dumb devices, but complex, let's say, cloud systems. And it's built for machines and constraint devices. And most importantly, MQTT was built because of the need for having a reliable communication channel, which at scale over unreliable physical channels, like mobile networks or even satellite links. MQTT is really designed for this. The usual use cases and the usual industries, and this is just a very small example, you see MQTT a lot, is connected car. MQTT is a default protocol for all connected cars for most vendors on Earth, basically, especially if you're also looking here at Europe. Most vendors will work with MQTT. Industrial IoT, or here in Europe, we have Industry 4.0 as a big strategic thing. MQTT is one of the prime protocols used here. Also logistics, telecommunication, and IoT messaging middleware in general is something where MQTT is used by thousands and hundreds of thousands of companies. Also from technological use cases, very often there are requirements like push communication, so like this instant snappy communication. This is reliable communication over unreliable networks, which we already talked about. And it's really built for constraint devices and for low bandwidth and high latency environments. And also what we see a lot also in our customer base is that this industrial message bus, so connecting your whole factory and even factories with MQTT is something a lot of enterprises do today because of the simplicity. And also the technological challenges we saw for the Internet of Things also applies heavily for industrial Internet of Things. And if you look at, so this is something a few years ago, people talked about what protocol should I use. This is over for a long time. So, so MQTT is the prime protocol for connecting anything. And this is, yeah, basically the protocol if you do Internet of Things. But meanwhile, while MQTT had a success story, there was another technology which was on the rise, and this is Apache Kafka, and I believe most people know this technology. It's an open source project, and it really took the industry by storm, the tech industry, and it's much more popular than other similar technologies like RabbitMQ, Apache ActiveMQ, and so on. And Apache Kafka is nowadays one of the most popular technologies in the industry. So what is Apache Kafka? Apache Kafka is a distributed streaming platform. It's open source. It's one of the most popular projects on GitHub, and it's the most popular Apache project. It's used by more than a third of the Fortune 500 company, and the number is rising here. And it's very often used as a central messaging and distributed stream processing application for connecting your business and your business applications. And it has some unique strengths. This is why this is an important technology. It's optimized to stream data between systems and applications in a very scalable manner. It supports scale out with multiple partitions for topics and on multiple nodes. So even if you have this huge Firehose topics, you can really push a lot of data through an Apache Kafka system. And it's really perfect for inter-system communications, especially if you're inside a trusted network, if you have stable IP addresses and connections between the applications, and if you have a limited amount of producers and consumers. So this is not something which grows exponentially, but if you know what applications you have and what microservices you have, for example. So this is something you can usually plan ahead. So it's really like the central communication thing for your business, where you can connect databases and your applications and also do some stream processing. So this is something Apache Kafka is really good at. If you look at it from a technical perspective, Apache Kafka has a concept called topics, and a topic is partitioned. And there are some producers and there are some consumers. And producers produce messages on topics, and consumers then consume from these partitions. And you can really nicely scale out your applications by having multiple partitions also per topic for the different consumers. So this is on a very, very high level, how Apache Kafka works. But the question here is, how does it fit in with IoT? So I think it's pretty clear to many people why Apache Kafka is so popular and why it's one of the most important technologies built in the last few years for system-to-system communications and messaging. But how does it fit in with IoT? Let's do a quick reality check, because this is a discussion I've seen a lot of times, that people are unsure how IoT and Apache Kafka fits together. And the reality for IoT is, if we go to the challenges again, so we have many clients connected over the internet. Very often we have architectures which use load balancing solutions as a first line of defense very often. But Apache Kafka, how it works, the protocol, is really that you need to know your Kafka nodes. And so if you're using a general purpose load balancer, like if you're on the AWS ecosystem, and if you're using the load balancers provided by them or by other cloud providers, or if you have a Citrix NetScaler load balancer or a F5 load balancer, then it's a tough challenge to address the right nodes in Kafka, because you usually don't want to expose your Kafka IP addresses to the public internet without having a first line of defense. This is not something you want to do for production systems most of the time. But the problem here is load balancers effectively act as a proxy. So really, it's pretty hard to speak the Kafka protocol over the public internet. And this is something which you should really be careful, especially if you're doing it with vanilla Apache Kafka and not having another distribution, which adds some features here. It's pretty hard. And so basically, sometimes it's not even possible to use Apache Kafka over the internet at all for IoT devices, because it's pretty hard, and you need to distribute because you need to expose your Kafka nodes directly over the internet. There are solutions out there if you really want to do this, but it's usually not considered a very good pattern to do this. Also, scalability, when it comes to scalability, is IoT devices are usually segmented to use individual topics. So especially when MQTT is in the mix, these individual topics very often contain unique identifiers of devices. So what it's really about is in usual IoT deployments, we have millions of topics. So we have customers up to 100 million topics in a MQTT system. So topics are something that is, especially with MQTT, really used very, very heavily. And it's super important for a publish-subscribe system. But for Kafka, Kafka is not designed to handling thousands or hundreds of thousands or even millions of topics. And it could, so it really depends on your installation, but I have never seen multiple hundreds of thousands of topics on Kafka, because this is not what Kafka is built for. But if you have a few topics, it's super great. But if you have millions of topics, Kafka doesn't work that way. But if you look at the IoT, so let's do a car example here. We have multiple cars, and this is what enterprises actually do. They're using these topic structures and sending it to the cloud, sending data to the cloud over topics, and each device has multiple topics. So we have seen deployments where even single devices can have thousands of topics for MQTT, which is great. MQTT can handle millions of topics. But if you would do direct, if you would partition this for Kafka, this would usually not work. So if you really want to do this, then you cannot have such a fine-grained topic structure. And another challenge here is constraint devices. IoT usually has constraint devices. And the Kafka client is not something that is very lightweight, because a lot of complexity in Kafka is on the client due to design, which is great for server applications, but it's not great for constraint devices. So there are, if you go into the technical details, there are a lot of challenges here you need to solve if you want to have Apache Kafka clients on constraint devices, and you don't have a great, by the libraries out there, you don't have a great configuration available when it comes to how you want to behave this. So you can do this. We have seen people doing this, but this is really hard to do for most companies. And then again, we have this reliable network. So you want to use a protocol which really has support, is built for unreliable networks. Apache Kafka assumes that the consumers and producers are there to do their work most of the time. Of course, it can buffer a lot of messages, but it's not designed for having like reconnects of multiple millions of consumers and producers. This is not something Apache Kafka is designed for. So you want to have this producer and consumer rather static. So we're not talking about thousands of producers, consumers you usually have. You can do this, but again, if you go to larger scale, Kafka is just not designed for this. So but Kafka is well suited for data ingestion of cloud native server applications. It's really perfect for this, but it's not well suited for IoT device data connectivity. So to summarize what I just said, so there are some technical challenges, and so you can, the slides will be available after this webinar, so you can read through this in detail again. But again, Apache Kafka is really not designed for communication over the internet at scale. It is designed for system communication at scale if you're in the backend. This is really where it shines. So now the question is, how can we use the best of both worlds? So we've seen MQTT on the one side, and also we have seen Apache Kafka on the other side. So, and as you might expect, there is a really good way to bring both technologies together in a very elegant way. And it really looks like both technologies are made to be together. But now we'll give over to Magi, and she will talk you through how to bring both worlds together.
Okay, so hi from my side, and thank you very much, Dominik, for sharing those information. Let me quickly share my screen. So, okay, so as you said, the question is not Kafka versus MQTT, but it is how to integrate both worlds together for an IoT end-to-end data pipeline. And I'll tell you a little secret if you can keep it for yourself. MQTT and Kafka is really a love story made in heaven. So they both really fit very well together. But as you know, it always takes two to tango. And we heard a lot of MQTT and Apache Kafka. And I now will have a closer look at the MQTT part, especially at the HiveMQ part. So HiveMQ itself is an enterprise MQTT broker that scales to more than 10 million of always-on devices. So we can really have a lot of devices here that are publishing data via the MQTT program. It is based on the standard IoT protocol MQTT, so that means we have all the MQTT features here. We have the MQTT protocol versions 3 and 5 that are supported, and also in an interoperable way. But it's not only an MQTT broker, it's also a connectivity and messaging platform. So that means that you also can connect your enterprise softwares. So that means on the one side, you have your IoT devices, let's say, for example, cars out there, sensor data, whatever. So you have the IoT devices, and on the other side, you have your enterprise software. That's also able to be integrated here with HiveMQ. And yeah, let's have a closer look how that looks like. So on the one side here, you have the devices that are connected via MQTT and over Unreliable Networks to HiveMQ, the MQTT broker, that is able to solve the communication problems between the clients and also to the backend systems, so the enterprise systems like an Oracle database, Apache Kafka, or any other IoT platform you may have in your backend. And HiveMQ itself is also able to run everywhere. That means Docker, OpenShift, Kubernetes, on any cloud, on-premise. That's all possible with HiveMQ. Okay, so that means on the one side, you have HiveMQ with fast and reliable communication of IoT device data. That's really ideal for the communication over unreliable networks. And that is also able to connect millions of IoT devices. But on the other side, you have Apache Kafka. Apache Kafka that is optimized to stream data between systems and applications. That needs trusted networks for communication, and that is able to connect a limited number of communication partners. So that is really for the backend part where it comes to enterprise systems. So now the question is how to integrate both. So how do you connect them together? And there's one solution that's called the HiveMQ Enterprise Extension for Kafka. That is an extension for the HiveMQ MQTT program that allows seamless integration with Apache Kafka. Because inside the HiveMQ extension for Kafka, we have the native Kafka protocol implemented. That means we really have here a Kafka producer and consumer. The extension for Kafka is able to give end-to-end persistent messaging guarantees. So here, no message is lost during the communication between both systems. Of course, we have a bidirectional communication, so from MQTT to Kafka and also from Kafka to MQTT. Of course, high scalability and resilience is supported. I'll tell you a little bit more here in a minute. And we also support different schema registries. So on the one hand, we have the local schema registry, and on the other hand, the Confluent schema registry. We also will have a closer look at that later. And yes, of course, multiple Kafka instances are also supported. So what does this mean? First of all, HiveMQ Enterprise Extension for Kafka is able to stream data to the different Kafka distributions that are out there. So it could be the open source Apache Kafka product, or something like the Confluent platform, also the Confluent Cloud platform, or also AWS Kafka. And of course, if you want to, you can also connect different Kafka clusters to the HiveMQ Enterprise extension for Kafka. So that means if you have an open source Kafka cluster and Confluent Kafka cluster, no problem, you can connect both to the same HiveMQ cluster. Okay, high scalability and resilience. So that means if you start your IoT project, usually you will start with a small use case. And if you want to forward MQTT messages to a Apache Kafka cluster, no problem, your HiveMQ Enterprise extension for Kafka will do that for you. But with time, your use case will grow. So you will have more IoT devices that are connected to your HiveMQ, and you need to scale the MQTT broker yet to be able to handle all those data. And the good thing here is HiveMQ itself as an MQTT broker is scalable, and also the HiveMQ Enterprise extension for Kafka is scalable. So really the whole system scales with your needs. So if you need more, then you can handle more with those systems. And as I said, no message is lost. If Kafka is for whatever reason at the moment not available, the HiveMQ Enterprise extension for Kafka will queue the messages until Kafka is available again. So we really can here have the guarantees of both protocols. And also you have an extreme throughput. So hundreds of thousands of MQTT messages per second is no problem. So we can do that with our Kafka extension. Okay, bidirectional communication. So as I said, sending MQTT data from IoT devices via the HiveMQ cluster and the HiveMQ Enterprise extension for Kafka to the Kafka cluster is no problem. And on the other side, you also can forward Kafka messages from a Kafka cluster via the same extension to your IoT devices. And that is possible in multiple different ways. And now it gets a little bit deeper into the technical details. On the one side, let's start with the MQTT to Kafka side. So usually what you're doing here is you map your topics. That means if you have only one side, an MQTT topic, then you can decide to which Kafka topic the messages should be sent to. So that means you have really a one-to-one topic mapping. That is possible, and maybe for some testing that is really good, but usually you have millions of MQTT topics, as Dominik explained earlier. And on the other hand, you have a limited number of topics on the Kafka side. So that means you somehow have to aggregate the MQTT topics to a Firehouse Kafka topic. So that is also possible, for example, with using topic filters. So millions of topics can here be aggregated to one Kafka topic. If you have a closer look at the other way, the Kafka to MQTT way, you can also do a one-to-one topic mapping. That is possible, but you also can do more. You can have a one-to-many topic mapping or a many-to-many topic mapping. So you're very, very flexible here in what you want to do. And you also have here the possibility to transform messages. So that means using parts of the Kafka message to create the MQTT publish. And we will have a closer look here. Okay, so first of all, MQTT to Kafka is pretty simply explained. The MQTT topic here is used as the Kafka key, and the MQTT payload is used as the Kafka value. And you can decide on which Kafka topic this MQTT topic should be published. On the other side, you have a little bit more flexibility. That means as an MQTT topic, you can choose either the Kafka topic or also the Kafka key is possible here. And the Kafka value can be used as an MQTT payload here. Or we have a closer look at the Kafka value. So if we have something like just here, a client ID and a message, we can also use this to create our MQTT publish. So if you have a look at the MQTT publish, you see something like a $sign and some brackets, and data variables in the HiveMQ Enterprise extension for Kafka. That means they are replaced at runtime with the data that is coming from the Kafka record. So in this case, we will replace the client ID with client 1 and the message with whatever needs to be sent. And you can do even more with that system. So using this variable replacement, you also can do message multicasting. So if you want to multicast Kafka record, not only to one topic, but to multiple topics, for example, to address multiple clients, then you can have a list of client identifiers, for example, in the Kafka record, in the Kafka value, and use that for variable replacement. So as you see, we have one MQTT published that uses the topic with a variable called $brackets client ID. That's the same with all 3 MQTT publishers. And at runtime, HiveMQ Enterprise extension will create from one Kafka message 3 MQTT publishers, for example. So you can do that with even a bigger number of clients, of course. That's just an example here. But you see, you have here really the flexibility to create your MQTT publishers. And by the way, not only the topic and the publish can be set dynamically, all the MQTT publishers can be set dynamically with fields of the Kafka message. So, if you start your let's say IoT use case and you want to integrate Kafka with that, usually you start with a small design. You design your whole system, and Kafka really doesn't care about the message formats. You can even have completely different messages in one and the same topic. So Kafka doesn't care. And Kafka also does not verify messages or the correctness of messages that are sent to the topic. And in the beginning of a system, that is usually no problem because you designed your system that it can work seamlessly together. But the truth is, systems are evolving, and also message formats will change. And changed message formats will lead to interrupted data flows. And if no data can flow, then you will get really into troubles. So therefore, we have schema registries. Schema registries guarantee the correct functionality of the messaging. So that means if I want to send a message via Kafka, then I have to make sure that the message is in the specific schema, in the specific format. And with the schema registry, I can ensure that the schema is really met. On the other side, you really have message validation. That means if a message comes from Kafka and you want to forward it via the HiveMQ, the MQTT program, then you can validate the message using the schema. And if the message is not valid, so it doesn't fit the schema, then this message won't be published over the MQTT broker. And another cool thing is that you have the schema evolution. Schema evolution means that you can have multiple versions of the same schema. So let's have a new version of the schema, and you can use the old and the new version at the same time. And the communication partners, let's say the HiveMQ Enterprise extension for Kafka, for example, knows which version to use. So that's pretty cool, and you have a little bit more flexibility here. Okay, so what does this mean for the HiveMQ Enterprise extension for Kafka? So we support, on the one hand, a local schema registry. That is a part in the extension for Kafka itself, where you can store schemas for the messages that are coming from Kafka. And at the moment, we support that for JSON and Avro messages. And the main use case here is to validate the messages that are coming from Kafka, that they're really fitting the schema. So let's have a look at the architecture. It looks like this. If you want to forward messages from Kafka to your IoT devices, then you pull the messages from your Kafka cluster, get the schema from the local schema registry, validate if the message is correct. And if it is, then you can publish it to your IoT devices. If it is not correct, then the message won't be forwarded to your IoT devices. So that is pretty cool for a start. But if you want to have schema evolution, then we also support the Confluent Schema Registry. That supports schema evolution itself. But at the moment, the HiveMQ Enterprise extension for Kafka is only able to use that with other messages. And it looks pretty the same like the other architecture, but you have the Confluent Schema Registry as an external system here. So you get that from somewhere else. It's not included into the Kafka extension. Okay, and of course, HiveMQ as an enterprise MQTT broker comes with an administrative user interface, our so-called HiveMQ Control Center. That is a pretty cool tool if you want to have deeper insights into your MQTT broker. What's going on, to see how many clients are connected, which clients, to which topics they are subscribing, and so on. And the HiveMQ Enterprise extension for Kafka now also adds a new view to this control center. That means you can see here how the messages are flowing from your IoT devices to Kafka, and also the other way around. Messages that are read from Kafka, how they are flowing to the IoT devices. And we'll have a closer look into that because I'll show you something. Okay, so as a conclusion, the HiveMQ Enterprise extension for Kafka is able to connect millions of IoT devices over unreliable networks to integrate those data into multiple Kafka clusters. And also to one Kafka cluster, but multiple Kafka clusters are supported as well. So you route your IoT device data to multiple Kafka clusters and allow therefore for a single IoT platform to support different types of devices and forward device data to different backend applications. So also bidirectional communication is supported by the HiveMQ Enterprise extension for Kafka. That means pulling information from multiple Kafka clusters is also possible, and distribute the information to your millions of IoT devices. Of course, because it is a native integration or extension for the HiveMQ MQTT broker, it supports also all the MQTT 3 and 5 features. Okay, then millions of MQTT topics can be aggregated to one or a few numbers of Kafka topics using MQTT wildcards. No message will be lost because of the end-to-end persistent messaging guarantees, and that the Kafka extension also stores or queues the messages if Kafka is temporarily not available. And you also have the monitoring of the MQTT messages written to Kafka in our HiveMQ control center. Okay, So let's have a closer look, because I also prepared a small baby little demo for you. But here's an overview what this demo shows to you. So we have, for this demonstration, 100 simulated cars. That cars are producing data, and that data is forwarded to HiveMQ via MQTT. And HiveMQ has the HiveMQ Enterprise extension for Kafka installed, and that means all the data that is coming from the 100 simulated cars is also forwarded to Apache Kafka. And you see it here, we have multiple MQTT topics that are now aggregated to one Kafka topic, the Kafka topic sensor data here. And what we're doing now is using KSQL and have a look at the sensor data that is coming from the cars. And especially we have a look here at the value speed. And if a car is faster than a certain threshold, then we will create an alert. And that alert will be forwarded also via the enterprise extension for Kafka to HiveMQ. And here we are using the Confluent Schema Registry to validate that the data is correct. Yes, so data is pulled from Kafka and forwarded via the HiveMQ to all the devices. They also have an topic that is called alert. But I also can have, for example, a mobile application that subscribes with a topic filter to all those alert topics, and then I see all the cars that are faster than my threshold. And I will simulate the mobile application with the MQTT CLI, which is a tool for the terminal to see which MQTT messages are coming here. Okay, so let's have a closer look. Oh no. I have to log into the HiveMQ control center. Okay. Oh, I do not have to log in. Okay, then I show it to you like this because it runs on another system. Okay, so that is the HiveMQ control center, which means basically that is the dashboard where you see everything that is going on your MQTT broker. And you can also have a closer look here at all the devices that are connected to the broker. And here you see also the topics where the clients are subscribed to. And you see that is also the alert topic. And here I have a Confluent cluster Kafka running. And here in the topic sensor data, I get lots of messages that are produced from the sensors of my cars. And using KSQL, we will have a look at the speed, and if a car is faster than my threshold, then it will generate a new message on the alert topic using that schema that you saw right now. Okay, that usually takes a few seconds to see all the data that is generated. And here on my mobile app, let's say on the MQTT CLI, you see data that is coming in. So everything that is over the maximum speed of 35 will be alerted here. Okay. So thank you very much. And I think we will have a Q&A session right now.
Okay. Cool, thank you, Magi. So we have indeed some questions. So it seems like we won't, because we have a lot of questions, it seems like we don't get to answer all of them in this live session, but no problem. We have the community forum where we will answer all questions about this presentation you had, and also you can ask additional questions in case some questions come up. So we would be very grateful. You should now see a poll window. If you like the presentation, how we can do better next time. Also, if you'd like to have a follow-up with us to give you a private demonstration of this or discussing a use case, also fill this out, please. And I will now start answering a few questions. So one question is someone is asking that Kafka, due to the inefficiency of Kafka containing 1,000 of topics, is how does HiveMQ solve this? Is the HiveMQ broker completely in memory to overcome this problem? No, the HiveMQ broker is not in memory. The HiveMQ broker is designed for persistent messaging, similar to Apache Kafka, but it's due to how the MQTT as a protocol works. So MQTT is designed for very lightweight topics. So topics are really, really lightweight. And the HiveMQ broker is basically designed for massive scalability of topics. And so it's due to the system design, basically. But it's a broker system. So Apache Kafka, for instance, can also have as a record of also delivered messages. HiveMQ is usually used as MQTT is used as a brokered messaging system. So it means if a client acknowledged that a data point was processed, HiveMQ is able to delete this on the server side. So we get another question from a person who is asking, is Sparkplug supported? And for people not familiar with Sparkplug is a protocol built on top of MQTT, designed for industrial systems, which is an extremely important protocol for manufacturing and in the industry. So HiveMQ supports Sparkplug because it's based on MQTT. Sparkplug assumes 100% MQTT compatibility, and so we support Sparkplug. And there is also more to come. So we are one of the companies who are on the specification committee of Sparkplug. So you can expect more to come to have even deeper integration with Sparkplug solutions. And of course, you can forward your Sparkplug messages to Kafka and vice versa with the Kafka extension. So someone's asking if we can share the resources afterwards. So yes, we will share the resources. We will share the recording. As soon as it will be available, we will also share the slides and some additional resources for you if you want to dig deeper into some specific areas. So someone is asking how to use Python together with HiveMQ. This is super easy. MQTT is an open standard, a protocol. There are multiple client implementations for all programming languages from C to Java, to Go, to Rust, also to Python. So there is the Eclipse PAHO project, which has some client implementation, and it also includes a Python client you can use. And another person is asking, how code intensive is the HiveMQ for Kafka extension? And this is really the beauty of the solution. It doesn't require any code at all. This is pure configuration. So you can even update this in your system if for some reason you want to have additional use cases. So without any downtime at all, you can decide what kind of data streams you want to consume from Kafka and forward it to MQTT, and also what kind of data streams from MQTT you want to forward to Kafka. And this is without any code at all. This is pure configuration, and this is pretty simple. So most of our customers are up and running, have their production things up and running in a few hours. So it's really simple. And if you're interested in this, we're glad to show a live demo and show it for your use case. A person is asking, can we send data directly from device to Kafka broker, or is the MQTT broker always required? So of course, if you have a device which implements the Kafka protocol, you can always use this, of course. There are some challenges that we outlined here in this presentation. If these challenges apply to you, there might be a problem. Then you definitely want to have MQTT. So usually, as soon as device connectivity is in there, MQTT is the protocol to use. And really, if you are using MQTT, you should really be careful and only use solutions which support 100% the MQTT standards. Unfortunately, cloud providers have a proprietary version of MQTT available. Yeah, this is for most people is a problem, because MQTT is an open standard, and you really you want to avoid a vendor lock-in on the MQTT side, because then your devices are locked into a specific vendor. This is, from a risk perspective, most enterprises. This is not something you can do for many enterprises from a risk perspective. So yeah, you really need, for device connectivity, MQTT, and also for backend communication, Kafka is a very good addition if you're already using this. And the Kafka extension for HiveMQ really brings the best of both worlds. Okay, then somebody is asking how IoT and MQTT can help for the shop floor manufacturing area. So this is something we had a webinar last month, where we showed in detail how to do manufacturing with MQTT. And also here, the Kafka extension here is used a lot for these use cases. So we will be glad to follow up, and we can also send you the link to this. It is on our YouTube channel. So it's the links are here on the thank you slide. So you can just watch the recording or reach out to my team directly, and we can help you. Someone is asking, security is also a major concern. Which can be secured better, MQTT or Kafka? It really depends. If you have an enterprise Kafka distribution, they also support security. If it comes to device security, though, MQTT is designed for devices over the internet. So, you use usually TLS for encrypted communication. We also have on our blog, there is a series for security, how to do this properly. But the short answer is it's extremely simple with MQTT to do. For Kafka, there are also best practices to secure this. So both are used for enterprises, but for different use cases. Okay, then there's a question, what is the limit of HiveMQ? The number of MQTT clients. Also, can you speak a little bit about the limits of the Kafka extension as far as data throughput is connected? So HiveMQ, a HiveMQ cluster can connect up to 10 million devices. And we have customers doing this. So also remember, IoT devices are usually coming and going frequently. So yeah, there is not really a limit here. So also when it comes to data throughput, HiveMQ provides throughput of hundreds of thousands of messages per second. And with the Kafka extension, we tested up to 800,000 messages per second to a single to a Kafka cluster. And basically, if we would have used a machine with more CPUs, then this can increase. So really from a limit here, there are of course limits as in any systems, but HiveMQ is really designed for this massive IoT scale. And the largest Fortune 500 enterprises in the world are successful with their deployment with HiveMQ. Okay, so we're already over time. We have still a lot of questions open. So thank you everybody for being that engaged. This is really, really awesome. So we will answer all our questions on the community forum. So we will also send you the links afterwards to every participant. So thank you for taking this time. This was really a pleasure. And yes, okay. See you next time.
So thank you, Magi and Dominik, for your presentation, and also special thanks to you for joining us today. We hope you enjoyed this session. Like Dominik said, we will upload the webinar on our YouTube channel, and I pasted you the link in the chat. You will also get everything via email, so there's also a link to our monthly newsletter in which we give you updates on our upcoming webinars and on our content. So like Dominik said, the remaining question will be answered on the community forum, and yeah, I think that's it. Thanks everyone for joining, and see you next time.
Yeah, thank you. Bye.
Bye.
Thank you. Bye.